Welcome to the Earth Science Classroom. In this video, we're looking at GMOs as part of the agricultural unit, and we're looking at a more holistic view on this subject. We're looking at GMOs, of why they were created in the first place, what they actually are, how they are implemented and put into today's crops and agriculture, and when this all began and how this developed as an industry through the past 70 to 80 years. This is the Earth Science Classroom. Ever since the time of the hunter-gatherer and the transition to a more settled, certain geographic location where humans can domesticate animals and grow crops in a certain area of fertile soil around major rivers in the Middle East and Europe, that enabled humans to grow in population and start to develop the ability to grow and survive on more crops, higher yields, and the same acreage or same amount of land. And this was enabling human population to exponentially grow in population. Now we have over 8 billion people spread across the world in various areas of density and cities, and the amount of land used for agriculture and growing crops and animals is ever increasing. So the constant demand and need to supply a hungry population of humans with the amount of food required is always there and always increasing. So the fact of GMOs and the fact of science and engineering and the ability to take the DNA and the genome and to understand how all of that works genetically through biology and apply it to ecology and agriculture in a way that will develop faster methods of growing crops and more efficient ways to produce more food. And GMOs was one of those answers, in addition to irrigation techniques, crop rotation, various other modern green revolution techniques. GMOs played a huge part in that revolution. Now, a GMO is a genetically modified organism. So it could be a crop, it could be an animal, it could be anything, organic. And the ability to take a seed or a plant or an organism of your choice and change or alter the genetic makeup of that chosen material to have a end result that would benefit the farmer or the industry. So there's going to be a point, a reason, a purpose for taking that certain crop and changing the DNA to change it for the better, for beneficial purposes. And the engineering has enabled us, and the understanding has enabled us to take whatever crop we want and redesign it in a way that suits the farmer, suits us, in terms of pesticide use, in terms of certain pests, in terms of certain soil quality, and reducing the effect of climate fluctuations and seasons and rainfall and evaporation rates and wind damage and the issues of soil erosion. So all these different factors have been taken out of the equation when it comes to growing crops and producing a higher yield. So now we know what GMOs are. When this happened, well, it was initiated around the mid-1940s, around 1946, and this coincided obviously with the ending of World War II and the ability for developed nations to turn their mindset into not war, so to speak, but other areas of society to improve society, to get back to normal after World War II, and the jump in discoveries by certain scientists. So this was a giant leap in science and understanding and technology, and the transfer from DNA and RNA of genetic material, and with the ability to start in the mid-1940s and then progress the science with more and more discoveries, more and more understanding, to a point where the GMO practice is an integral part of modern day agriculture. The introduction of GMOs is a fascinating topic in regards to history, in regards to the effect on the crops, the effect on population, and the effect on the farming industry in general. But the actual genius of this whole topic is how scientists were able to achieve this in the first place. So the actual GMO is decided before the crop is even touched. They decide on what they want to change about that crop. What is it about the trait or characteristic that they want to either take away or add in the crop? Now, for example, corn. Now, BT corn was a great example, is a great example of the first real large mass-produced crop that GMOs assisted in producing a larger yield of corn for the average farmer. Now, there are certain pests or insects that live on the corn and eat the corn. And what they wanted to do was they wanted to eradicate this issue of this pest. And rather than just spraying thousands of tons of pesticide and killing every bug, this one bug had to be taken out or taken away. So they decided to change the actual corn DNA to have placed inside the DNA with bacteria and growth and various stages a naturally occurring pesticide that the corn can naturally develop inside its own body, own corn material, and naturally have a defense against this one insect that was eating the corn. So now you have this corn that is resistant, and you don't have to add any more pesticides to that farm. So you also have the death of all these pests because of the natural resistance and pesticide that's in the corn, and they can regrow that same seed and have a whole farm and whole field just on this BT corn. So it was genius to adapt the corn for this one issue. And from there, we have taken various other traits and characteristics and issues in other crops with other pests or perhaps certain soil types or climate types and adapted that genetic material to compensate for whatever. So this is just amazing how they've done this. And that was first done in the mid-1940s. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on earth science.